Welcome to Third Angle, where our homes live in harmony with nature. I'm your host, Paul Hames from industrial software company PTC. In this podcast, we share the moments where digital transforms physical and meet the brilliant minds behind some of the most innovative products around the world, each powered by PTC technology. Now, you probably know you have to cut down on plastic, use less water, and switch to an electric car. But have you ever considered the role your house plays in living more sustainably? I'm not just talking about adding solar panels. The concrete, the bricks, the mortar used to build our houses, and even the contents all have considerable impact on the environment. In fact, buildings actually account for nearly 40% of global energy-related carbon emissions. But we can't exactly stop building houses. So when it comes to being more sustainable, what can we do? How do we create homes that work for us and work for the environment? Now, Joe Stuart is the founder of Warehome, a small architectural practice based in East London that specialises in low-energy, sustainable homes and is supported by PTC's strategic partner, Ineo UK. Our producer, Hannah Dean, met Joe at his own home, the project which launched him on this journey way back in 2012.
Hi, how you doing?
Hello, Joe. It's Hannah.
Nice to meet you.
Nice to meet you.
So we're here outside our house in East London, which is the first home we built as Warehome. So obviously we're in the first house that we designed and built as Warehome, and this kind of is the genesis of the company as it is now. It started out of the fact that I couldn't afford a place to live in London. I couldn't find anything that had anywhere near the level of comfort that I felt as someone who works quite hard, that I felt like I kind of deserved. So I was looking to find an opportunity, and I stumbled upon this site, stumbled upon the opportunity to design something. I've always been in design and engineering and tinkering, and I've always had a love for architecture. The key here is, we're building homes. We've got people building for themselves, so they care. It has to be a sustainable development, and it has to be interesting. Something that's just a standard two up, two down. We're not the best people to do that project for you, because we'll get too into the detail, will probably cost too much because the amount of time we spend to get the design just right. But when it comes to creating a home, we're not just facilitating a utilitarian approach to building a building. We're creating, hopefully future memories for people. So we've just entered the building. We're in sort of our vestibule entrance hall. We've got sort of the glazing on the north side here that just brings a lot of light into this space, which is, only a few square meters. On this level, we've got our sort of main bathroom, which is sort of accessible for anyone visiting. So on some of the surfaces like the floors and the walls of the bathrooms, where we're seeing the potential for a lot more abrasion from people coming in and using their shoes or chemicals and water, we've used basically a material here, a seamless surface, which is a water-based polymer that is like a concrete sort of finish. So it's got that grey kind of patinaed, almost cloudy look, but is sort of not quite as got quite as much embodied energy as a concrete finish would be. So as an architectural practice, we specialise in Passivhaus, which is it's actually a German approach to analysing how your design works, both looking at how it works thermally, but holistically. So when you think of how much energy you need to heat the house, how much energy you need to cool the house, where you need to put the windows, it's a very thorough, typically German approach to assessing the design, rather than just building what looks pretty and then going, I hope this works. So in the case of this house, the application of Passivhaus was key to essentially leaving us with a home that doesn't have a heating system. So we're currently sitting in maybe 21, 22 degrees, and it's only being heated by our body heat, the appliances that are in here, your fridge and your freezer, and then the sun from the outside. So in the summer months, it's key to make sure that we're shading the house correctly, and in the winter months, we're essentially just heating it ourselves. So I think there is a huge amount of Swedish influence, not only because my wife is Swedish and her family is Swedish, but also because I think the way the Swedes, the Japanese, and also sort of areas of Europe work with smaller spaces, tighter spaces, functionality of rooms, of separation between rooms, I think that all feeds in really well. But we see a lot of the Largon principle coming into how we work, and Largon meaning sort of just enough or just so. It's essentially not too much, not too little, kind of that Goldilocks position. We're now half a floor down where we've got our spare bedroom and our sort of wet room space. This is where, when we have guests staying, it's almost like their own little space because they've come in the entrance and down, whereas the rest of the house is up and out the way. We also use it in the summertime because we use the sun to heat the house. It means that the lower down the space we are, naturally, it's slightly cooler. So when we had the 40-degree plus temperatures last year, this was a nice, cool space that we could retreat to. So we're now in the spare bedroom, which is pretty much the same footprint as above in the main bedroom. Everything in this house is modest. It's a modest footprint of a house, so there's nothing, really lavish, but we've got good space either side of the beds. The key to making it feel bigger is the dual aspect of having glazing both sides, meaning that we've got light that's coming through and balancing and avoiding the dark spots that can often make a space feel smaller. Secondarily, we've used every wall that we can for storage. So when we've come into this space, we've actually walked through the wardrobe space rather than coming in and seeing a wardrobe that often sort of removes that open square kind of feeling that gives you the most, I guess, the best perception of space. The key for us, because we've attracted a lot more similar projects where they are constrained sites, it's key to look at the quality of every metre squared and not how many you've got. So we use that term, the quality of each metre squared, not the quantity. And that really is works really well in this space and a couple of the other ones we're working on so far. So one of the key materials we use here is CLT. So as you can tell, it's just like a big block of wood. So basically it's the standard pieces of timber that you might see in a normal timber merchant, but it's gone through a process of being glued together and cross-laminated, so it gets this inherent strength in multiple directions, and essentially becomes this massive piece of wood that can be cut into pretty much any shape, and they're complete wall pieces. So the benefits of something like this is it allows you to get some of this thermal mass, this material that's on the positive side of the building. So you're trying to keep your house warm, so you want to be able to store that energy, or if you want to keep it cool, you want to store that energy. And the timber does it in a way that isn't throwing lots of concrete or lots of steel or these heavy block materials that have this embodied energy that we don't want to have. But it allows us to get some of that mass still to help control the building, to give us a lot of stability in the building, a lot of resistance and flexibility when we're talking about some of the incidences that have happened over in Turkey with the earthquakes. It's a very resilient material, and it's probably about 3 decades old or coming up to 3 decades old, so it's relatively new. But the use of timber is absolutely hundreds and thousands of years we've been using it to create structures. So this is just a newer way of doing that. And we like to sort of try and look at the use of this and other mass timber elements within our buildings to try and help with managing that. In layman's terms, embodied energy is the amount of energy it takes to create something. So when you think of steel, it has to be created in a forge. There's a lot of heat that goes into there. There's a lot of energy going into bending, fabricating, drawing these materials out. When you think of a tree, the tree kind of grows itself and we cut it down. And yes, there's energy in cutting it and transporting it, but it's far less than having to, dig something out of the ground, apply a lot of heat, pressure to make it a usable material. So timber's obviously the one that we're drawn to as a low embodied energy material, but on top of that, it has the potential to offset the energy. It's called carbon sequestering, and it's the fact that in the right conditions under managed forests where they're replanting appropriately, you're actually able to capture some of the carbon. It gets stored in the building. The byproduct of managing these trees actually helps sort of manage more carbon dioxide in the environment, and it's this lovely cycle of once you've used it in the building, it can then sort of almost go down a peg and down cycle to the next appropriate material, right the way through to being pelleted and burnt, and then that carbon gets released back into the environment and then starts that whole cycle all over again. So I can appreciate the question of whether or not it's as safe as building in a traditional manner. Obviously the idea of concrete or block or brick, it's got that stability, that mass, that feeling of security. But actually, be it mass timber, be it other sort of off-site techniques, the structural requirements are the same. The building has to hold itself up, and arguably the lighter weight the structure, the less it has to work, and therefore the better it is in those respects. In the UK, fortunately, we don't have the issues of earthquakes, where we've seen a lot of brick and block and concrete buildings, absolutely devastating communities over in Turkey as well as around the world. But you're seeing timber buildings surviving. You're seeing questions about fire safety, but there's huge studies that are going on in Canada and Australia that are showing that materials like CLT, as we've talked about before, is very, very predictable in how it works, whereas steel and concrete isn't. So I think it's an easy thing to tarnish timber with a bad name because it might be weaker or it might be that it will burn. But the reality is that's not the case. Here in the UK, we don't have a flourishing timber industry like they have in Europe and like they have in America and Australia. So there isn't the want politically to say this is a wonder material, this is what we should be using. And I think that unfortunately gets in the way of what is a very, very sustainable and very considered material that's been used for hundreds, if not thousands of years to create homes and spaces that protect us from the environment. So I think it's a very safe choice as long as it's designed right. And that's the key on all of these design technologies or, traditional technologies. If it's not done correctly, it's not going to work. If it's done right and it's tested in the right ways, then you're just as safe. So we're now standing in the wet room. This is the space that's sort of adjacent to the guest bedroom. So it's often sort of not an ensuite, but it feels like that when people are staying. What's great about it is it's an open shower space. We've got about 2.7 metres by 1.6 metres. So it feels like a nice big space. We're standing in here with plenty of room. So, even in a space like this, the wet room, there's a great opportunity to choose better materials to be more sustainable with that. We've got the same seamless floor in here, but we've also used it all the way up the walls. It's what's created this wet room. But rather than using tiles with grout that have sort of, porcelain tiles of pretty high levels of embodied energy, this, again, it's a water-based, VOC-free polymer, basically. It's a very thin application. And so really when you're trying to create a waterproof space, it was designed to go into swimming pools. So it's the perfect choice, but it's also a more sustainable choice. It's not the cheapest way of finishing a space, but it means that at the end of its life, it's much less energy that's being lost. It's much easier to sort of remove it than have a load of broken mashed tiles and grout and everything. It's a thin layer that can be sort of ground off. But really, it's just a consideration of materiality that often is overlooked because the standard approach is, we'll put tiles in the bathroom. Obviously, on top of that, we're conscious of the amount of water we use. We're only a two-bedroom, really a two-person, 2.5 person with our little one. We've got the water management, so we're making sure that we're using atomizers on our taps, everything just to reduce. And I think that's often an oversight when it comes to architecture. In design, it's reduce, reuse, recycle, and that first R is often lost. So if we can reduce the amount of water, heat, whatever it is we're using, or materials, then that's a really great start. So leading up from the bedroom, we go up to one full floor above ground. This is where we've got our little snug. It's about 2.5 metres wide by 3.5 metres. It's not huge, but it's sort of the perfect distance from the sofa to the TV, which we've craftily hidden as one of the sort of frame ones, so it looks like a picture when we're not using it. But essentially, this is a space where we retreat to at the end of the day. I think there's always a balance, especially on smaller homes when you're trying to get your entire life into a smaller space. It's a real balance to make sure that you've still got some of your own personality in the design. I think you can start with the structure and how it works and considering the sustainability, where the windows need to go to make it work well, where, what materials to use within the build-up. But at the end of the day, how you dress it, how you finish it is the thing that, as a user, is, I think, critical. We were fortunate in this occasion to be able to do that as part of the journey, part of the process, to understand how the light moves around the space and how we might want to change things. But it's not a luxury everyone has, but I would sort of implore people who are looking to sort of go along this journey and building their own home to go through some of the processes of chucking a VR headset on and walking through the house in a virtual space. So when we're designing houses now, we're fortunate enough that over the last 7 years we've been getting more and more sort of technology coming into the process, and we work sort of in quite a lot of detail with our modelling to get sort of very realistic models both for manufacturing so that we can make a lot of our projects off-site, be it with cassettes, which are sort of prefabricated walls, be it CLT or glulam. So it's really important to get that modeled up correctly, but it also then allows us to either celebrate that in the case of this project that we're showing you here, which is one of our projects in Muswell Hill, where we can then take the client through that journey of the space that we were talking about earlier to understand how the light will work, how they can use the space differently, and literally put a headset on. They can stretch their arms out and not quite touch the walls, but get a real understanding of how much space they have got or haven't got. So we use this VR tool and 3D modeling tool throughout the design process with our clients, from early concept where we're trying to just understand window placements, or we're trying to understand room configurations, and we'll do that with very dumb blocks and forms to make it quite quick to model up and get an understanding. And then, as you can see in the model we're looking at now, this is essentially a photorealistic impression of what their home will be. We actually have their exact speakers, their exact sofas, the exact joinery. Maybe they won't have these plants and whiskey bottles on the side, but it's that, again, adding a personality, and the clients can sort of fall in love with their place before we've even built it.
That was Joe Stuart. Now, to design and model their bespoke buildings, Warehome needs a program capable of parametric modeling, and they've chosen to use Creo, PTC's 3D computer-aided design software. It's time to meet our expert, Brian Thompson, who heads up PTC's CAD division. Now, Brian, we've spoken about Creo on previous episodes, but never about its use within architecture. And I guess this shows just how versatile Creo is in working across different markets, correct?
Yeah, I really love this example, Paul. I totally agree. It really does show off Creo's versatility. I mean, we really have a robust business for decades within the architectural segment. Most of it is in the development of really aesthetically beautiful architectural components that go into homes or buildings. We have a broad array of customers that do that kind of design in Creo. But as we're going to discuss here on this podcast, boy, this particular customer is taking it much, much further. They're taking it into, construction of large structures, which is really similar to how you build any other large structure like a ship or so forth, but it's becoming a bit more industrialized. And this particular customer is using technology in Creo that's fundamentally designed for the discrete manufacturing industry and applying a lot of the techniques associated with traditional product design in the design of architectural structures. And that is creating a tremendous amount of precision and a tremendous amount of detail in the design. It gives them excellent foresight into manufacturing construction costs and so forth. And they're starting to use like standardized components in the manufacture of their products and so forth. That there are examples out there of customers building very large structures with Creo. This one is an extreme example, but it's a really cool one. And talk about a highly engineered large structure. If you've paid attention to PTC's website in the past, say, 3 or 4 months, we had an announcement about our involvement in a very, very significant development in the world of fusion. And that is this experiment that created positive energy as a result of a fusion reaction at the National Ignition Facility here in the US. We're talking about an absolutely massive engineering structure, all developed in Creo, but highly, highly, highly engineered, right? Every component in there, highly engineered. They know every detail about that assembly. Of course, they need to. It's all designed from a pure engineering point of view, even though as you look at it, you could very well think of that as a big architectural project, right? So really cool. And it's nice to see someone in the more, traditional architectural domain taking those concepts and using Creo and applying Creo in, frankly, similar ways, but, obviously on a little different scale and with a little different design intent in mind.
Well, Warehome's main forte is Passivhaus. This is low energy, an innovative solution for their customers, their clients that are looking for a property that is a bit different. And of course, because they're dealing with both the design and also the materials for the construction, they become, let's say, more involved in the project a lot earlier than, let's say, you would do with traditional architects. And of course, to do that, you need control of the project, and you also need visibility and control over the bill of materials, something that's really tough to fully grasp, fully lock down within the engineering world. But Creo helps them with this, right, Brian?
Oh, yeah. I mean, this is one of the great strengths of applying engineering discipline to a project like this, because this has been a challenge for design engineers from the very beginning, especially in today's world where there's a lot more awareness of the impact of the material choices that you make in even the sustainability or the environmental impact of the design that you choose to eventually implement in your product. And the same applies to building a structure, to building a building, to building a home. And the fact that Creo has been developed to give engineers the freedom to try out a variety of material choices, to apply lots of different design techniques on the components that they're designing into their design, and to then help them understand just, how much material are we actually applying here? Can we improve the efficiency of the use of materials here to reduce the carbon footprint of this design? I mean, that is like at the forefront of what design engineering systems can do. And so it's another good reason why you have a strong connection between a company that wants to do environmentally conscious structure design or home design with Creo and the fundamental strengths that Creo has, the complete management of all the components, understanding of all the materials and how all that impacts the overall design in terms of environmental impact is something that Creo is really strong in anyway. So it's really a great fit.
Thanks to Brian and to Joe for showing us around his home, the first ever Warehome project. Please rate, review, and subscribe to our bi-weekly Third Angle episodes wherever you listen to your podcasts, and follow PTC on LinkedIn and Twitter for future episodes. This is an 1860 production for PTC. Executive producer is Jackie Cook. Sound design and editing by Ollie Guiu. Recording by Hannah Dean, and music by Rowan Bishop.